Day 1. Information Data Assurance. 613. It's a summer school session, which I indicate as SS20, 2020. Okay, don't have to worry about that. We did an overview, so we talked about cybersecurity landscape. Okay, so right here, cybersecurity landscape, the whole realm of this idea of cybersecurity. We talked about how often things are changing, how the internet's impacting it, and data. Okay, look at how data is being accumulated by Google, Facebook, LinkedIn, and you could name all kinds of. One student said everything is gathering our data. We should be able to know and have some say in that data, but it's hard to do. Okay, and then we talked about privacy of the data and what people are using it for and what should they be or not be using it for. Next thing we mentioned, we live in this global community. Global community. Yeah, the world, because of the internet, the world is as one almost in some respects. Then we moved into, I started talking about characteristics. A number of things we have to be familiar with. Okay, so first we have to figure out who's involved, who are the stakeholders, who are involved, and we have to understand some of them are good, some of them are bad, some of them are in between. All these players. Okay, so we got to be able to categorize who. And then we'll talk about the different things that they do, okay, and what kind of threats, how we identify those, and so forth, the characteristics of securing data. I mentioned principles, the key principles, confidentiality, who can see what, integrity, the data's got to be accurate, and availability. We have to make the data available to the right people, and we got to make sure it's accurate. And this all relates to data. And I asked now, what data states are there? Data can be at rest, in transit, and being processed. And what kind of cybersecurity countermeasures can we do to protect that data, even though there's such a huge amount changing all the time? Well, we can use technologies, we can use different products, we can have procedures, and guess what this word is supposed to be? It's supposed to be policies. Yeah, we can have different policies, and this really all relates to people too. I always talk about the 4 peoples. We have products, procedures, policies, and people. Technologies allow us to have all those. And in people, we can have people who accidentally make mistakes, people who do it on purpose, we got bad people, we got some people in between, we have just users, we have such a wide range of people making use of our data. Now, in order to manage that, we need some type of legality. We need certain laws. We'll talk quite a bit about, actually, during the next 3.5 weeks. We'll talk quite a bit about the laws, what relates to what, HEPA for the health industry, FERPA for the educational industry, and there's a whole group of them. When do you have to disclose? When there's a breach, we talk about this personal identifiable information. We talk about what laws there are to help us regulate all this data. And you just can't have a law for everything. Okay, you can't have a law for everything. There's got to be some code of ethics that can guide us in the right direction in terms of making a decision and not have to relate back to some law. In fact, I've always often wondered when somebody says, well, I didn't break the law, just that comment in general says, you're doing something wrong. You know, if you have to question the validity of what you did, you're probably doing something wrong. Yeah, it may not have broken the law, but it's probably something that's wrong. So, next thing, talked about the course, curriculum, packet tracers. That's you. You'll complete those. I realize the course is a little dated, but that's okay because what it does still helps us build a foundation, and then the current events are what we'll take care of in class. Plus I've got some information to bring us up to speed. At this point, the labs are done in class in groups in some cases. In a lot of cases, they'll be in groups. So, for example, today they did an individual lab, then they compared it with their peers, and then you get a little bit of this expertise changing or sharing of information. Plus, it's good practice to work, to collaborate in work. It's really important. The Linux box, we want to get up to speed. There's a little form to fill out. You follow the modules down. Fill that out. So we're going to use the Linux boxes as soon as tomorrow. Security Plus, it's a group of objectives. You can download that. And then I ask the students to start marking those objectives. They strike through if they don't know it at all. Highlight it if they're really confident in their expertise, and then just leave all the rest of them, and we'll refer back to that. I'll eventually have a place for you to submit it. A+ certification, you'd be qualified after you finish the programs to take that. CCNA, if you finish all the networking classes, you'd be qualified to sit for those with some extra study. I also mentioned if you have comments or ideas that could make the course better, by all means get those to me. One page. Data. It all starts with data. We take data, and nowadays we use computing devices and software to convert data into information. What do we use information for? People use information for, man, who knows? Look up. You can look up you can have a flower. You can look up what kind of flower it is and see if it's poisonous or whatever, just by taking a picture of it. Okay, I mean, there's all kinds of places people use information. Devices. Okay, right now here in the spring, people are out planting. They can use GPS to plant their fields and change. There's all kinds of. You take all this data, so then this information is just a device to a device, right? You know, it's, run our utilities. There's just all these things. The information the idea is to bring some value to all of these different things we use it for. And the value can be good or bad, I guess. Data is represented, we can represent it as text using, for example, American Standard Code of Information Interchange. A bunch of ones and zeros represents the letter. Data can be represented as pure numbers, characteristic of mantissa, and right at this point you don't need to know exactly how. We can represent sound or audio using binary digits. Okay, images and graphics can be represented using ones and zeros. Either this really falls into two categories: either raster or vector graphics or images. And video, we can represent frames, video frames, using a bunch of ones and zeros. Finish up, talk about digital. Digital can be represented binary digits. Those binary digits can be represented in either decimal or hexadecimal form for us humans. Right? Here, the computer likes the digits or the on and off circuits. And that's it. That's it for day one. The